Mortgages are a type of loan. We talked about residential mortgages in Canada as another type of loan. And the thing is, if you're working in the banking industry, or, if you're a business and you have a mortgage, you're going to be asking yourself, how much do I owe? Besides calling up your bank and asking, you want to understand how they calculate it. We want to be able to do the same thing. We want to be able to mechanically do that. Well, the first thing is you have to know is that we know mortgages are long-term investments, but mortgages are kind of neat because they have a interest-bearing schedule for most mortgages. Now, there's different types of mortgages, but generally what a mortgage does is the interest on a mortgage is normally compounded semi-annually, 2 times a year. And because of that, that's 2 compounds a year. And normally in your mortgage, you pay it once a month. So what we got is compounding is semi-annually, and the payments are monthly. That is a general annuity. We know that that is an ordinary general annuity, meaning that we had to calculate this I2. Remember, we had to do the calculation of I2. So that's exactly what you need to do with a mortgage, is to do the exact same things we've just done above, but we're going to need to consider it as a general annuity. So we got to get a value of C and a value of I2. And we know that the value of C is the number of compounds per year divided by the number of payments per year. That will give you the value of C. And then to calculate the I2, it's 1 plus I to the power of C minus 1. We've done a few examples in the past of that and on your assignment. So effectively, when we have a mortgage done, we have to get a revised version of the interest per period, or the periodic interest rate using this calculation in order to calculate I2. That then gets used to calculate, as we've just done with the retrospective method. This then can use in this formula right here, a present value formula, in order to calculate the value. So effectively, what we're really saying is, look, a mortgage is no different than the other loan, except that it's an annual general annuity, and we have to revise the interest rate to a periodic interest rate using the formula that we've talked about lots in the past. That then is going to be used in order to use the retrospective method in order to calculate the value of the amount owing on the mortgage at any point in time. So the balance at any point in time is the future value of the amount borrowed at the reference point in time, less the future value of the stream of payments to the reference point in time, which is exactly what we've done for the retrospective method. This is the formula, and this is the formula that we've just finished. So effectively, when you're doing a mortgage, what a mortgage requires you to do is just that extra one step, which is to calculate the I2. So here's a little example, and then we'll be done for today. A $50,000 mortgage loan is written with a 20-year amortization period, 3-year term, and an interest rate of 4.5% compounded semi-annually. Payments are made monthly. Now, what this means, because terminology here, just to be clear, it's a mortgage 20-year amortization period. That means you have 20 years to pay off the mortgage. The 3-year term is the time at which you need to renegotiate the interest, okay? So mortgages are longer than a year. They're probably 25 years, could be different lengths of time. But the fact of the matter is the bank is so uncertain of the future, they're not going to allow you to say, okay, here's a good interest rate and stick with that interest rate forever. You might not want to do that either over the course of the loan. That is not forever. So what happens is a mortgage, the interest rate gets renewed every so many years. So what mortgages tend to have is a renewal point on them in 1 year, 2 years, 3 years, 5 years. Depends on the actual mortgage. Different mortgages will offer different packages, but let's assume this one here gets renewed after 3 years. So we're going to look for what is the balance at the end of the 3-year term. That's effectively what we're looking here for. And B, the size of the payments upon renewal for a 5-year term at 4%. So basically, we're going to say how much is this mortgage going to be paid off in the 3 years to get to there. So what we're doing then is taking the bits of information. Present value is $50,000, which is the mortgage. The number of periods, well, it's a 20-year mortgage. 12 payments a year, or 12 per year is 240. The interest rate on it is 4.5%. We know it's compounded semi-annually. That gets split in two to be 2.25. And the value of C, which is 2 over 12. So the number of compounds divided by the number of interest periods will give that 0.16. Repeating, that just means 16666. You got to take that value of C, put it into the I2 formula, which we've done here, and we get a new value of, this is the new periodic value, which is 0.0037. We then take that and we throw that in our formula. This is the formula, the typical formula we just looked at back here. Okay. So it's a future value formula. So we know that we've got 50,000 is the value of the loan, the present values formula, I should say. The payment, we plug the value in for the revised version of I, so it's 1 plus that, minus how many periods there are, 240. And that will give you the amount of the payment. So we can calculate what is the payment of the mortgage. Okay, so there's the monthly payment for the mortgage. Now, then, in order to find out what the value of it is after 3 years, we got to figure out what the balance after 36 payments is. Well, that's 3 years, 12 months a year times 3, which is the future value of 50,000 after 36 months, and the future value of 36 payments already made. So these are the two things that we got to do. So we're going to take the future value of 50, we're going to plug it into that formula, and that will give us that. Future value of the 36 payments, we're going to put that into that formula, and that's that. That minus that is $45,024. So effectively, after 3 years, this $50,000 mortgage, you will have paid down less than $5,000. You'll have a balance of $45,000 left at the end. And Part B says the renewal is handled the same way as a new mortgage whose original principal equals balance. So effectively, the present value of the new mortgage becomes the present value, or the value at the end of the period of the old mortgage, or the old version of it. So that transfers to there. There's 17 years left in it. So the total number of periods is 204. The interest rate and the new mortgage is 4%, and it's a semi-annual. It's 2% per. We calculate the value of C, which is 2 over 12, 0.16. Get the value of I2. There it is right there. And we can actually plug that into the formula in order to calculate the revised payment. This is not hard to do. It looks intimidating. It looks more intimidating than it is. The only way that you can really reduce the intimidation, though, is to do some examples. So what I've done is I got a batch of examples here. And if I'm not mistaken, I have 3 and 5 exercises done. So what I'd like you to do is take a look at them.